Hello, welcome to GPS Manipur. In this particular video, I'm interested in teaching chapter called Gravitation. It is for class 9 physics and it has been demanded by one of my friend. Okay, my friend is a teacher, biology teacher. So she have asked me to make a video on this chapter. The reason is she said, okay, student find this chapter difficult. So she want me to make video for her students. So her name is Raksa and let's start. Let's start the chapter called Gravitation. Okay, so let's go. Gravitation. Have you heard about the term gravitation, or uh, have you ever thought that why is the thing falling down to the earth? If I throw this up, this object will fall down, right? Have you ever thought why is this object falling down? Okay, there was a guy called Newton. He was thinking about this. He was sitting under an apple tree. I don't know whether the story is true or not, but he was sitting under an apple tree and he was thinking about this. Okay, so let's say what Newton was thinking. Okay, let us discuss what Newton was thinking, what was in his mind. So let's say this is earth. Okay, let's say this is earth and Newton was sitting under an apple tree. Let's say this is an apple tree and he was sitting somewhere here in an apple tree, under apple tree. Now this apple falls down. I don't know how true the story is, okay, but it is very important. Let's say apple falls down. Now first thing is, are you sitting inside the earth? Are you sitting on the surface of the earth, or are you sitting outside the earth? Then answer is, we are actually sitting on the surface of the earth. This earth is round and we are sitting on the surface of the earth. Okay, sometimes you don't, why don't you think, okay, sometimes if you are sitting on the surface, think of football and think you are sitting on the football this side. If this is football, you're sitting by the side of the football. Why are you not falling down? Why are you not going away? Are you getting the point? Are you getting the point? Similarly, the Newton was thinking, why is this apple falling down? Why is this not apple going away like this? Why not going away like this? Why it is coming down straight? Then okay, there must be something that earth must be pulling this. That is the idea he was thinking. Or he asked another question. There is moon. If apple is coming down to the earth, why is not the moon coming down to the earth then? Or is the earth attracting only this apple? Or is the earth attracting only the object that is, if I throw up, this will fall down, only attracting this one? Earth likes apple, earth likes pencil too much, earth doesn't like moon, so it is not attracting the moon. Is it so? He started thinking. Okay, he started thinking and he said, okay, the apple must be falling down because earth must be having some force. Earth must be pulling this. There must be some force, and let me name this force as gravitational force. Okay, and he said same thing with moon. Moon also must be pulled by earth. But why is the moon not falling down? We can understand this by take a rope, tie a stone and started rotating like this. Okay, what you are doing is you are rotating you are tying a rope and you are rotating like this. This object is moving. Let's say this object is moving like this. Okay, you are rotating like this. Okay, now what will happen if I leave this? If I cut the rope, what will happen? If I cut the rope? Then this stone will fly away. Okay, sir, which direction will it fly away? It will not fly away straight like this, it will fly away in this direction. Keep this also in mind. Okay, the stone tends to fly away this direction. So what is this? Sir, it will fly away straight like this, and the direction is, if I draw a line touching only one point, this is called tangent, right? So it is tangent to the surface. It is tangent. Okay, the direction of force will be tangential force. Okay, it will be in tangential direction. Okay, it is written in a textbook. Sometimes students used to get confused. It is here. Okay, in your second page of the chapter, you'll find out that in absence of the force, the pebble or the stone, okay, pebble means stone, will fly off along a straight line due to its inertia. Such straight line will be tangent to the circular path. That is why whenever you release the thread, the pebble flies off along the tangent to the circular path. Okay, that's what I mean here. So let's go next. So let go through whatever I've taught. Have you ever wondered why apple falls from a tree? Have you ever thought why apple is falling down? Okay, why does not the moon fall to the earth like the apple? Second question, what keeps planet moving around the sun? Why is not all the planet going in the sun? Why is the planet moving around the sun? Why is not that sun having gravity and it is attracting? So the answer lies in the fundamental force, the nature called gravitation, the force of attraction between any two objects having mass. Okay, so let's discuss. I don't know whether I'll be making. What is that? Okay, so now we were discussing this. Now there is some force. This is some force. Now there is some force here. This force is not letting this stone fly away. There is some force which is tied to the center, which is not letting this fly away. This force is called centripetal force. Centripetal force. Force that is to the center. Centripetal force. Okay. If I cut away this rope, it will fly away. That means there is no more centripetal force. Okay. Similar like this. There is moon is also moving around, right? Moon is also moving around the earth. Moon is moving around the earth, so earth must be having some force with the moon. There must be some force. The force that is between earth and the moon, sir, rope, then no having. Yes, I understand that there is no rope. There is some invisible force between the earth and the moon, and that invisible force is called gravitational force. Okay, that invisible force is called gravitational force. Okay, so an apple falling down to the earth, it is because of gravitational force. Okay, and moon moving around the sun, a moon moving around the earth, it is also because of gravitational force. Or planets, earth, Mars, Jupiter, Saturn, Mercury, Venus, all these things rotating around the sun, moving around the sun, it is also because of gravitational force. Okay, so gravitation is a force. Gravitation is a force of attraction. Gravitation is a force of attraction. The force, there are two kind of force, right? For attracting force and repelling force. Now force of attraction means it will only pull. Gravitation can only pull, it will not push away. Sir, give an example. You know magnet, right? You know magnet. If I take magnet and if same side, then it will push, right? One side it will push, another side it will attract. Have you tried with magnet? You know magnet, right? Magnet, if I play with magnet, if I keep like this, then it may attract, and if I change the direction of the magnet, then it will repel. Okay, similar like that. Okay, there is magnetic force can attract also, can repel also, but gravitational force will not do like that. There is nothing called repelling force in gravitation. Gravitation is attracting force. Okay, it's a force of attraction that exists between any two object. Any two object will have force of gravitation. Sir, that means my phone is here in my hand and I'm sitting here. Will there be force between me and my head, between me and my phone? Yes. You are an object. Your phone is an object. You have mass. Your phone has mass. There is a force of gravitation between you and the phone. Are you getting the point? Okay, so object, between any two objects in the universe that have mass, this force is always attractive. This always attractive means pulls object together, it will not repel, it will always attract. Force of gravitation is attracting force, not repelling one. And x along a line joining the center of the two object. X along a line joining the center of, let's say this is, I'll tell you with an example. Let's say earth and moon. Okay, earth and moon. Okay, this is a very wrong diagram drawn here. So actually what it must be, is, sorry for the wrong diagram, Sorry for this, just a moment. Okay, let's say there is earth. This is my earth. This is my earth. Okay, and here is my moon. This is earth and this is moon. So moon is rotating around the earth and this is called moon's orbit. Moon's orbit. Okay, so now this is what I've explained just before in this diagram, right? This is what I've explained here. Moon is around the earth, it is rotating. So why it is rotating? Because there must be some force between this one. Otherwise look, earth, it is rotating, it is changing its direction all the time. The moon is changing the direction all the time. If it is changing the direction, then it must be tied to the earth, tied to the center. There must be some force. There must be some force which is letting this moon have this path. Okay, there must be some force, and this force, Newton called this force as gravitational force. I have already explained, and it is written here also. On an apple tree, apple fell on his head. This made him think, if earth can attract apple, can it also attract the moon? Newton realized that the same force that makes object fall to the earth also keeps the moon in its orbit around earth. So if something that is falling down to the earth, apple is falling down to the earth, that means there is the same force letting moon not go away also. Moon, okay, is not going away from the earth, or it is not coming to the earth. The reason is also gravitational force. Okay, now the speciality of Newton is not that he said apple fell down to the earth and there must be gravitational force. Not this. Many other scientists and philosophers have said this. There were many Indian scientists like Brahmagupta, Vaskaracharya, even Aryabhata, I hope so. They have talked about gravity. They have talked about gravitational force. But speciality about Newton is universal law of gravitation. He gave some law and he said, okay, this is the law. This is the rule which will be obeyed not only on earth, it will be obeyed not only on moon, not only on other planet, it will be obeyed all over the world, all over the universe. Everywhere you go, if you go to the alien planet also, the force, the law will be same. And this is called universal law of gravitation. He gave a rule. We'll discuss that rule very soon. It is very interesting rule. He gave a rule and that rule will be applied wherever you go. Wherever you go, the rule is same. That is the speciality of Newton. Okay, so what does the rule says? So he studied, and now after apple fell down on his head, he studied and he said, okay, he made a rule. Okay, it took years. Okay, it's not that one day apple fell down to him and he said, okay, this is gravity, so let me make a rule, and he gave the rule. Not like that. He studied, he thought, he analyzes. He's a very brilliant person. It took years, and he formulated something called universal law of gravitation. Okay, so what does this law says? This law says, let's say there are two mass. Let's say this is one object. Let's say this is one object, and this object has mass m. Mass is equal to m, and there is another object. It has mass is equal to, let's say, small m. Mass, you know mass, right? How much kg? There are two objects. Okay, I'm keeping one object is this one, another is this one, and I'm keeping like this. It has some mass, this one also has some mass. If I keep like this, now sir, mass, will there be force between these two? Yes. What kind of force? Attracting force. Okay, one thing. Sir, how much force? Force means there must be amount, right? How much force will be there between these two? Will the force between these two, how much will there be the force between these two? And he said the force between these two is directly proportional to product of their mass. Directly proportional to force between these two is, first point is, force is directly proportional to product of their masses. Directly proportional to the product of their masses means force is proportional to m. Okay, it's directly proportional, means if there is more mass, Proportional meaning, you know the proportional meaning? Meaning if there is mass is more, force will be more. If this mass is more, force will be proportional. Means if this one increases, this side if you increase, force also will increase. This is the meaning. Proportional meaning is this one. If you increase one side, another side also will increase. If there are more mass, more force will be there. Are you getting my point? Are you getting my point? Okay. So the first thing is force is proportional to mass, product of their masses. Second, directly proportional. Second is invert. This is one is directly, another is inversely proportional to the square of distance between them. Sir, what is the distance between them? Let me say distance between them is d. Okay, so second for law says, second step says force is inversely proportional. Inversely means downside. Square of distance between them, this is another very important one. Square of distance, force is 1 by d square. What does it mean? If this is the two object, what is the distance between two objects? That is d. Okay, and inversely proportional to d square. What does it mean? If the distance, if the distance between these two, if the distance between these two is more, there will be less force. Mass is more force. Distance is more, less force. Distance is more, distance is more, less force. Force will reduce. If there is more distance between these two, longer the distance, farther the distance, force will be less. That is the meaning of inversely. You know, this directly means more mass, more force, and inversely means inversely to distance, meaning more distance, less force. Inversely proportional. Okay, so what have we written down so far? First step was directly proportional. Force is directly proportional to product of masses. Second is force is inversely proportional to square of distance between them. Let me combine these two, so I can write down force m divided by d square. Now instead of proportional, if I put equal to, then I can always keep a constant. Always constant can be kept. So instead of proportional, I put equal to, so there will be a constant g, and it will be m divided by d square. And this is my Newton law of gravitational, universal law of gravitational. This one, force equal to g m into m divided by d square. What is m? What is m? Mass of the first object, small m, mass of the second object, d, distance between the center of the object, and what is f? Gravitational force between these two objects, m and m. G, this is constant, this is calculated, it has fixed value, you cannot change that, which is 6.67 into 10 to the power minus 11 Newton meter square per kg square. Okay, Newton meter square per kg square. Okay, sir, we cannot remember what is this Newton meter square per kg square. I'll explain it to you. What does law says? G m by d square. This is gravitational law, right? Let me write on g. So if I want to find out g, d square will go this side, so f d square. M and m, these two will come and divide downside, so m. Okay, so force is Newton. D square, d is meter, right? Newton meter square. D is Newton. D is distance, right? Distance is meter square. Force is Newton, divided by some what is mass? M is kg, another m also kg. So can I write on Newton meter square divided by kg square? Sir, I got the answer, Newton meter square per kg square. Okay, did I get this? Newton meter square per kg square here. So you don't need to get by heart. Okay, what do you need to get by heart? What do you need to remember is this number, 6.67 into 10 to the power minus 11. Okay, actually you can calculate this also, but remember this one, at least this much. Okay, this unit you can calculate and find out. Okay, let's go next. So we have discussed, we know the law. Now let us understand g, constant g. Okay, so what is it value? 6.67 into 10 to the power minus 11. Okay, the value of g, it was actually not measured by Newton, it was measured by another scientist called Henry Cavendish. Okay, in 1798. Okay, and he measured. This is calculated, this is like not, this is not calculated, this is measured. Yeah, they're using a device and measuring what will be the value of G. Okay, so he uses a very sensitive valence and he measured this G value. Okay, it tells us the gravitational force is very weak unless very large amount of mass is involved. So what does it mean? So G value is 6.67 into 10 to the power minus 11. Let us understand this. What does it mean? It means 6.67 divided by 10 to the power 11. If I take this minus 11 downside, it will become plus 11. Now 6.67 divided by 1, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. How much is this? 0.0000004, 5, 6, 7, 8, 9, 10, 11, 6, 6, 7. Very small. So this is very small. G is very small. Therefore, the gravitational force also will be very small. So gravitational force is not that strong force. Okay, sir, me sitting here and that boy sitting there. If force having between us two, then why we are not attracted? The force is very small. Gravitational force is there, obviously there, but it is very small. That's why you are not attracted. It is very small as compared to the Earth. The Earth is pulling you much stronger. Okay, because Earth is very big. Because of that, if Earth mass was small, the force will not be that bigger. Okay, we'll discuss this. But gravitational force is not that strong force. Let us discuss an example. Let us calculate the gravitational force between two students of mass 40 kg each sitting 1 meter apart. Let's say you are sitting here, your friend is sitting here. Let's say you have 40 kg, your friend also 40 kg. Let us calculate how much distance, how much force is there. Distance between you two is 1 meter. Now, sir, formula we know. Sir, M. What is M? Sir, 40 kg. What is small m? 40 kg. Sir, me also 40, friend also 40. Distance is, sir, 1 meter. Right? And G value is, sir, given 6.67 into 10 to the power minus 11 Newton meter square per kg square. This one also given, sir. Now, calculation force. What will be force? G M capital M divided by d square, M capital M small m divided by d square. Now what is G? 6.67 into 10 to the power 11, M 40 40 1 square, 6.67 10 to the power minus 11, 61600, 40 into 40 is 1600. And if I calculate, I got this. Now 1.6067 into 10 to the power minus 7, it is very small. It is 0.00000001067 Newton. Very small force. Can you look? The force between you and your friend is very small. So that's why the force is extremely small, about 10 million times smaller than the weight of a mosquito. A mosquito weight, mosquito weight. Okay, mosquito weight. You know the mosquito is a mass, right? It is attracted to the earth. The force, the mosquito weight, it is 10 times smaller than the weight of the mosquito. That's why you don't feel gravitational attraction between you and your friend. Are you getting the point? Why, sir? Why are we not attracted? This is the reason. The force between you two is very small. It is 0.000001067. This one, 0.00000001067 Newton. It is very small. That's why you are not attracted. And you know how to calculate now. Okay. So now another thing. This is another very interesting thing. I don't know. I'll try to explain. I'll try my level best to make you understand this one. Apple is falling down. Apple is falling down. Now observe how it is falling down. Apple is falling down. Let me explain you in separate page. Let's say apple is there, or let's say any object. Let's say any object, anything is, this is falling down on the surface. How it is falling down? Now this is falling down at the beginning, no speed, speed equal to 0. Now slowly when it reaches here, speed increases, speed is there, and finally before hitting the ground, the speed is very high. It's not that it is falling at the same speed, right? Speed changes. Sir, this one, slow in the beginning, it is not moving. Slowly, then it will change the speed. Speed is changing, Okay, it is not falling down at the same speed. Okay, speed is 0, speed is increasing, and speed is very high. And here it is, speed is there but very small speed, small speed. So speed keep increasing, speeds increases. So if there is change in speed, your speed is changing, speed is changing, that is called acceleration. You know, rate of change of speed, rate of change of velocity is called acceleration, right? Your speed is changing. So this object is falling down with acceleration, it is having some acceleration. Okay, now that is universal acceleration due to gravity. That's why we are writing acceleration due to gravity. Otherwise we can say velocity due to gravity, speed due to gravity, but speed is also changing. If speed is changing, that is acceleration. So acceleration due to gravity. When object falls freely under the influence of earth's gravity alone, they experience a constant acceleration called acceleration due to gravity. Object will experience an acceleration, and this acceleration, the change in speed is fixed, this acceleration is constant, rate of change of speed is uniform. Okay, rate of change of speed is uniform in rate of change of speed, acceleration is fixed. That's why the acceleration is constant. This is called acceleration due to gravity, and we denote by small g. There are two, one is g, this is constant, f is equal to g m by d square. This capital G constant, and small g is acceleration due to gravity. Gravity is having some acceleration. An object is falling down, and that apple is falling down, the apple will have some acceleration. Okay, that acceleration is called acceleration due to gravity. Okay, so let's go. Free fall is the motion of object under the influence of gravitational force alone. During free fall, all object, regardless of the mass, fall with the same acceleration. Free fall means if I leave this object, if I take this object, leave it, it will fall down. And if I leave this, I'm not forcing, I'm not applying any external force. It is just falling down because of gravity. Free fall, there is no other thing except gravity. There is free fall. Okay. And in free fall, when object is falling down and it is having some free fall, that is that object is having some acceleration. Okay, and that is acceleration, and that acceleration doesn't depend upon mass. This is very interesting. Let's say I made to fall this one and this one together, which one will fall faster? Or if I take this one, if I take this one and an elephant, and if I let it fall, which one will fall faster? Sir, elephant is big, that means elephant must fall down faster. Or let's say you and elephant, I take you to the top of 10th floor and both of you jump, which one will fall down faster? Which one? Sir, elephant. No, you two will fall down at the same acceleration. So acceleration will be same. Why? G is constant, acceleration due to gravity is constant, right? It will be same for all the masses. It is same. You, elephant or ant, it will fall down at the same speed. Sir, if it is like that, then paper and me falling down, then paper is like this, and falling down slowly, me then very fast. Why? Because there is air pushing this. If there is no air, no friction, okay, if and you and a paper falling down, you fall down at the same speed. It is just because of air friction that is letting the paper fly down and come down slowly. If there was not that condition, then if the condition was not there, then then both this object will fall down at the same speed. Are you getting the point? Are you getting the point? Okay, so now let us derive G. What is G? Sir, we know two force. One is force is equal to mass into acceleration. We know this force because of Newton's second law of motion. We have derived, right? Force equal to mass into acceleration. The previous chapter, chapter number 7. Another force is a force equal to G m by d square. So we know this one also. Now these two force, we can compare these two. So can I write on ma equal to G m by d square? Sir, a, instead of a, can I write on G? Sir, yes, acceleration, this is acceleration due to gravity. Now we are talking about gravity, right? So I can add on g m m g capital M small m by d square. G and no, m and m can cancel. So g will be equal to g m by d square. Okay, gm by d square. Sir, you said me and elephant will fall down together. How did you say that? Let me explain. Let's say you are this one, you, and this is very big elephant. This is elephant. You are falling down to the earth. You are falling down to the earth, to the ground. Okay. Now you are having, when you two are falling down, then you will have same acceleration. G will be same. Acceleration due to gravity will be same. Sir, G is g m by d square. Sir, g, this is constant. D, sir, it is distance between this one, d. Sir, m is mass of the earth. Sir, where is the mass of these two? Not having. That's why g doesn't depend upon the mass of these two. Look, not there in the equation. G depends only upon this mass, the mass of the earth, and the distance between them. Okay, it doesn't depend upon small m. Because of this, it doesn't depend upon the mass. Whatever the mass of these two may be, the force, the falling down force will be same. Or have you understood? If not, comment section is there. Please write down in the comment below. Okay. Okay. Now let us derive now. So I have derived that g, I've just now written down g equal to gm by d square. Or here I have written r square. Fine, let me write on d square. This is d square. This is d square. You can write on r square also, not a big deal. Okay. Oh, sorry. I've explained it wrongly. It is not r square. It is d square. Correct. I'll okay. I'll explain it to you. Okay, I'll explain. There is some catch here. Some catch here. Okay, I'll explain. But now let us understand first this one. Now, what will be g value? G I can calculate as, sir, capital G is 6.67 into 10 to the power minus 11 into, sir, what is m? M is mass of the earth. Mass of the earth is 6 into 10 to the power 24. It's very high, very big. And what is the radius of the earth? R is radius of the earth. So why radius of the earth? Sir, d distance between the two objects, right? So why radius of the earth? I'll explain. Now first let me explain this. So let's say this object is there. It is falling to the earth, and this is earth. This is object, and this distance is d, and this earth has some radius. Now the force between these two will be distance between these two, right? It's not the surface of the earth you are going to take. You are going to take the center of the earth, and you are going to take the center of the object. It's the force, the distance will be taken between the center. Okay, you are not going to take like this. You are going to take the distance between the center. But sir, this d is very small. I'm just falling down from top, like building height. It's very small. Earth radius is very large. That's why I'm taking this only radius in the equation. Okay, whenever you take, let's say, force between these two, so how much will be the force? Mass of this one multiply, divide by distance between the, so distance from where shall I measure? Sir, shall I measure from outer part, or I'll measure from center of this one and center of this one? I'll measure from the center. If I take earth and any object, I'll measure from the center of the earth and the center of the object. Getting the point? So distance is measured from the center. Okay, let's go next. And radius is also given, so I can calculate g. And if I calculate g divided by radius is, what is the radius? Radius is 6.4. Radius is 6.4 into 10 to the power 6. And when I cancel all these things, I got the answer to be 9.8 meter per second. After cancelling all these things, I must 6.4 10 to the power 6 whole square. After doing all this calculation, I'll get the answer to be 9.8 meter per second. So that is the value of G, 9.8 meter per second. So there may be a question, differentiate between capital G and small g. What is the difference between these two? Sir, G is from gravitational law of constant, right? Universal gravitational law of universal gravitational constant. This small g, it is acceleration due to gravity. This is 9.8 meter per second. This is, how much is this? 6.67 into 10 to the power minus 11 Newton meter square per kg square. So can you write the difference between these two? It's easy, sir. We can. Okay. So they may ask, exam they usually ask. Okay. Second, let's go next. Variation of G. So G is equal to Gm by d square. Okay. Now what will happen to the value of G if I increase the radius of the earth, or if I let's say with height? The earth, you know earth, right? Earth is not circular in shape, it is actually spherical. Earth shape is something like this, right? So earth has different, earth has shape something like this. So the value of G will be different on the different surface. It depends upon the height. The value of G at the equator, you know the circle, you know the earth, and earth used to have equator like this. This is the equator, and this is north pole, south pole. This is north pole, south pole, equator. Okay, the force of gravitation due to the gravitational force G value, acceleration due to gravity, G will be different here. It will be different here in the equator. Okay, it depends upon the height. Okay, if the height, if the height is, okay, if the height is more, if height is more, if d is more or r is more, if height is more, then G will be less. Okay, with height, as height increases, d decreases, G decreases. Okay, if the height is more, center height increases, G value, the value of G, universal, the acceleration due to gravity value will decrease. Okay, so G value will decrease. Very interesting point. With height increases, G value will decrease. Let us discuss an example. A stone is dropped from a height of 19.6 meter. Calculate its velocity before hitting the ground. It is asking us to calculate velocity, not acceleration but velocity. Acceleration we know, G is how much? 9.8 meter per second square. G value is same, acceleration A, 9.8 meter per second square. What else? A stone is dropped from a height of 19.6 meter. Height is 19.6 meter. Finish. Now what do we need to calculate? So we need to calculate its velocity. So we know A, acceleration we know. Okay, we know acceleration, we know height. Okay, so we need to calculate velocity. So we have the formula v square is equal to u square plus 2as. This is from section first chapter motion, we have derived this. Okay, if you haven't watched, you can go back and watch. Okay, so this equation we have already discussed. Sir, from that equation, we know u to your object is falling down from height, right? Object is falling down from height, so this object, it is falling down. So before falling down, velocity is 0. It is not having any velocity, u will be 0. So u is 0 plus 2 into a. What is a, sir? A is given acceleration due to gravity 9.8. So 0 square 2 into 9.8, and as is distance between these two. Distance is s. So v square is equal to 19.6 meter per second. So the stones hits the ground with a velocity of 19.6 meter per second. Okay, the stone which is at the height of 19.6 meter, it is going to fall down and it is going to hit the ground with some velocity, some speed, right? And that speed is 19.6 meter per second. In the beginning, what is the speed? 0. It is not falling down. 0 in the beginning. And what is the final velocity? 19.6 meter per second. In the beginning 0, and it is increasing and reaching 19.6. It is increasing. That's why acceleration. How much is the acceleration? So fixed, 9.8 meter per second square. I hope you are getting my point. I hope. Okay. I hope I'm not just barking. I hope some students are watching till now. Most of the student doesn't reach here. So I hope at least one student is here, reaching here. If anyone has reached till here, okay, please, it's a request. Write down in the comment below, sir, I have reached. Okay. If anyone is watching me now, okay, if anyone has reached here, so please write down in the comment below, I have reached, so that I'll understand you are watching. Okay, you are a serious student. Okay, let's go next. We have discussed already actually mass and weight. It is in the previous chapter also. What is mass and what is weight? Take anything, let's say this one. It has some mass. It is made up of something, right? It's not empty. Okay, it has something. It is something. So it has some mass. So weight, what is weight? Weight is how much force the earth is pulling this one. So what is the difference? Whenever you go to the market and say I need 10 kg of rice, what they do, they'll put 10 kg this side, and they'll put 10 kg here, and the 10 kg, it will be equal, the balance will be equal, and it will break. That is actually that is actually that is actually 10 kg. Kg is actually 10 kg. Okay, it is mass. You are bringing the mass of 10 kg, but since it is working under gravity, okay, you're putting stone this side, so that stone, that 10 kg, that 10 kg stone or 10 kg iron, you're keeping this side. Okay, so it is the gravity is pulling down that, and it is equal to that. That's why we are saying 10 kg. Okay, now, sir, why is this called mass? Let's say if I go to the moon, and when I go to the moon, I'll give a certain good example. Just a moment. Okay, now if I go to the moon, same thing. If I keep 10 kg of rice, 10 kg this side, will it be equal? Yes. If I take to the earth, and if I measure 10 kg of rice this side, 10 kg of stone this side, and equal. Now I go to the moon, 10 kg this side, 10 kg, will it be equal? Yes. Why, sir? Moon then very small, smaller than earth. So the gravitational force must be small. Why are they equal? I'll tell you very soon. Okay, let's say I have another time. Let me measure like this one, can you see in the screen, this one, spring balance, this one. Or sir, that smart machine, that electric machine one, this weighing machine one, this time electric one is working, right? Not that stone one, electric one. So that one, if I stand in this earth, and if it measure 40 kg, if I go to the moon and if I measure, okay, I may get around, okay, 7 kg. Sir, if I take this one, this kind of weight, if I take this one, and if I go to the moon, if I this rice, and this is 10 kg of stone, and they are equal, that means 10 kg of rice. If I go to the moon also, it will be same 10 kg of rice. But if I measure using this one, weighing machine, if I measure this one, and it shows 10 kg, okay, it shows 10 kg, and if I go to the moon, I'll find out that it is around 2 kg with this one. Now, so what is this happening? The reason is this kind of measure, this is measuring weight, okay, and this is measuring mass. In order to measure mass, we'll use this one, the old one that most of the shopkeeper are using, and the new one, this the weighing machine. Okay, actually they show kg. Actually, that must not be kg. That must be Newton. That is force. That is the force. How much the force is pulling that sugar? You are keeping sugar on that weighing machine, the electric weighing machine. How much the gravity is pulling that? That is actually force. That is weight. Weight is a force. Okay, that's why if I take to the earth has more gravity than moon. Why, sir? Moon is small, so it will have less gravity. The moon gravity is 1/6 times that of earth. around 1.6 times that of Earth. So in moon, the force will be less. So the weight will be less. Are you getting the point? Are you getting the point? So that weighing machine, the electric weighing machine that you are using, that will work only on Earth. But another one, that old one, take it to moon, it will work on moon also. But don't forget to carry the stone that is made on the Earth. Okay, the stone that you have made, yeah, you take that and go to the moon. It will work on the moon also. Okay, so weight depends upon gravity. Mass, go anywhere on the Earth, go anywhere on the universe, go anywhere on the any planet. Mass doesn't change. You go to anywhere, sir. What is my weight on this Earth, sir? If I measure, sir, I may measure around my weight maybe 60 kg here. If I go to the moon, how much will be? 10 kg only. So 10 kg, we are saying 10 kg, but that is not kg. That is actually Newton. I'm measuring using this kind of device. That is actually Newton. But we are saying kg because kg is actually mass. Kg is mass, and weight is Newton. Okay, weight is Newton. So one question may come: difference between mass and weight. They usually ask one question: difference between mass and weight. Okay, so what is the difference between mass and weight? So mass is the amount of a matter in an object. Wherever you go, the amount will be there. If you go to the moon, if you go to the Mars, if you go to Mercury, if you go to Sun, wherever you go, mass is there. Okay, sir, if I go to Jupiter, yes, the gravity is more there. So you will you have more mass? No, but your weight may change. So gravitational force acting on an object is weight. Okay, there is difference between mass and weight. It is a scalar quantity, only magnitude. Weight is a vector quantity, magnitude and direction. We have discussed about this magnitude and direction, vector quantity also. In first chapter, we have discussed this. What is vector quantity? What is scalar quantity? Mass is measured in kg, weight is measured in Newton. Okay, so mass, it is constant everywhere, wherever you go. Okay, and weight, it changes with location. Okay, if you measure here, it is different. If you measure, even if you measure on North Pole and here, okay, it will be different. It is different because the distance will be different, right? The radius of the Earth will be different. So force, it will, weight will change. Weight actually changes. If you measure on moon, then it will change, sir. Obviously moon will be very less, your weight will be very less, so you can jump more, enjoy more. Okay, but there is no oxygen, so you may not enjoy more. But okay, at least you'll have some fun, because you can, here if I just jump little bit like this, then in moon I can jump much more. Sir, I want to reduce my weight. Well, actually my friend was asking, he's very fat, okay, very fat, like me. Even I'm very fat. So he said, how shall I reduce my weight in 1 day? I need to reduce 5 kg in 1 day. Is it possible? Is it possible or not? Actually, according to this nutrition and all, it's not possible. But physics, it is possible. How, sir? How shall I reduce my weight? So go to moon. If you are 60 kg here, you'll become 10 kg there. You'll reduce your weight by 50 kg. Okay. So what to do if I want to reduce my weight? Go to moon. Okay. Go to Mars. Now Mars, you will increase. I think gravity is more there. Okay. So if I want to reduce my weight, what I have to do? I have to go to moon, and I'll reduce my weight. But mass will remain same. Okay. So next time, don't say, sir, I want to reduce my weight. Say, I want to reduce my mass. Okay. I want to reduce 5 kg of my mass. Then you'll be correct. Measure using beam balance. Beam balance means that this one, like this having, and used to be like this. Have you seen this? This is beam balance. It is measured using this. And this is spring balance. I've shown you before also. Actually, it is hanging like this, and there is a small slot here, and the small spring like this. Spring balance is there. Actually, something, there is hook here to hang. Okay, this is spring balance. So m is constant. Weight depends upon mass and gravity. Okay, mass and gravitational force. W is equal to mg. Sir, from where coming W is equal to mg? This one formula from where coming, sir? W is equal to mg. It is coming from force is equal to mass into acceleration. So force is weight here, mass is mass, g acceleration is acceleration due to gravity from this formula. Okay, so weight formula, w is equal to mg. W is weight of the object, m mass of an object, acceleration due to gravity in meter per second. Weight on different celestial body on Earth, it is 9.8 meter per second square. G value. If you go on Moon, it will become very small. Acceleration due to gravity. G. If I let object fall on Moon, it will fall down very slowly. 1.6. On Mars, okay, Mars has less gravity than Earth, so 3.7. Jupiter, it is very high. On Jupiter, it is much more. Sun, it is very high, 274. Okay, so this is weight factor. No need to do weight factor means how much with respect to Earth. With respect to Earth, it is 1 by 6, 0.38. Mars also, it has less gravitational force than Earth. Jupiter, it has more, and Sun, it is very high, 28 times. Okay, 28 times, so it is very high. 28 times means like if you can jump 28 meter here on Earth, you will jump only 1 meter on Sun. You cannot jump even. Very high gravitational force. Okay, so let's do one question, another question again. A person weighs 600 Newton on Earth. What will be his weight on Moon? Let's say he weighs 600 Newton on Earth. What will be its weight on Moon? Weight on Earth 600 Newton. G value, acceleration due to gravity 9.8 meter per second on Earth, and on Moon it is only 1.6 meter per second square. Okay, so mass, weight is equal to mass into gravitational force. So mass is equal to weight divided by g. Weight is how much? 600. G is how much? 9.8. So mass will be, if I divide, 61.2 kg. Now weight on the Moon. Weight on the Moon will be how much? Weight on the Moon, sir, mass into gravity again. Mass is how much? Mass is same, 61.2 into gravitational is, on Moon it is 1.6, so 98 Newton. So 600 on Earth, so it is 98 on Moon. Okay, or we can generally directly, okay, if it is on Earth 600, divide by 6, then it will be 100. This much will be on Moon. So 98 point something, I think, 98 Newton. So which is 100 Newton, similar. Okay, so the person will weigh 100 Newton on Moon, approximately 1 by 6th of their Earth weight. Okay, so this is general calculation. I hope you can understand. I hope you know this much calculation. I don't have much time because I need to finish the chapter, so that's why I'm doing it much faster. I hope you can understand, and if you find any difficulty, I'm always there. You can just ask me. Okay, so let me, what are the application of gravitation? What are the things happening due to gravity? Have you seen tides? No, sir, we haven't seen tides. There is no tides in Manipur. Have you heard about tides? Have you seen videos on tides? Tides means oceans, water is to come up, it is to come down. Tides, I don't know how to selection. Tides is because of Moon gravitational pull. Sir, if Moon is having effects on tide, why it is not having on us? We are attached to the Earth. Okay, the force attracted to Earth for us is very high. Okay, but water, the Moon has, if water surface and Moon surface, they are straight like this, the Moon can pull the Earth. If the distance between them, if Moon is here and water is here, it may not. This is ocean, let's say Indian Ocean or Mumbai, Goa. Okay, you are Goa here, Moon is here, it may not attract much, it will attract this side, right? But if Moon comes here, then water may be attracted like this. Okay, so there is, the ocean tides used to come, it is caused by gravitational pull of the Moon, or also the Sun. Okay, the Sun on Earth's water bodies. Okay, same thing with the sun coming up, so it will be because of Moon and the Sun. Okay, satellite motion, satellites, sir, satellites, we are launching satellite. Have you heard about NASA launching satellite, ISRO launching satellite? All the satellites are rotating around the Earth. So it is also because it will have some speed, so it will rotate around the Earth. Earth is having some gravity, so it will maintain that speed. If Earth is not having gravitational pull to that satellite, it will go away. Sir, how it is moving? It has some energy to move around the Earth. Okay, it is moving around. Okay, it is moving around the Earth, and Earth is having some force between these two. There is some force. Okay, so Earth because of the centripetal force needed for circular motion is provided by Earth gravitational force. So all planets orbit around the sun due to sun gravitational attraction. Okay, all the sun, all these things, it is because of gravitational attraction. So let me summarize what we have discussed. After that, we'll discuss the question that is given in a text. What we have discussed, sir? Object falling down. So object fall downs because of objects fall down, falls down because of gravity. Okay, force due to gravity. Force due to gravity is called gravitational force. Gravitational force. Okay, another is there is something called G. This is acceleration due to gravity, acceleration, which is 9.8 meter per second square. Sir, force formula is G m small m divided by d square. M is mass of the bigger object, small m small mass of the object, mass of the another object, distance between them, and distance between two objects is not measured like this from outside. It is measured from the center. It is measured from the center like this. Okay, distance between two objects is measured from the center, and this G value is 6.67 into 10 to the power minus 11 Newton meter square per kg square. Okay, and we know how this unit comes also. I have discussed, and we have discussed about weight versus mass. Sir, weight is force mg, mass is material, matter, quantity of matter. So weight, you need to measure weight by spring balance, or you can measure by weighing machine also. Weighing machine, digital weighing machine. Mass can be measured by balance. What is it called? This one common balance. This is for mass. Can you see? This is for mass. So weighing machine. So, and unit is this is Newton. Weight is Newton. Mass is kg. So we have discussed about weight and mass also, and also we have discussed that if d increases, then force decreases. Distance increases, force will decrease. If there is more distance, force will be less. Okay, so we have discussed about that also, and we have discussed that G is equal to Gm by d square. The gravitational acceleration due to gravity doesn't depend upon the mass of the two objects. Okay, it just depends upon the mass of the earth and the radius. Okay, radius of the earth. We have discussed this also. Now let's go to the exercise questions. Let us answer all the exercise question that is in your textbook. Let's go first. In which manner the force of gravitation will change when the distance between them is made double? Now we know the force. Force equal to G m1 m2 divided by r square or d square. Same thing, they are writing r here. We can write on d also. Now d will change when distance between them is made double. So distance you are increasing. m1 m2 divided by d you are making double. So if I'm making d double, it will be m1 m2 divided by 4d square. So it will be 4d square. So 2r square 4. So it is 4. This g m1 m2 divided by r square. This is f, right? R and d are same. Okay. I'm using d sometime. I'm using r sometime. Don't get confused with this. So instead of g m1 m2 divided by r square, I can write on f. So f divided by 4. So if I increase the distance by double, if you have two objects and distance is double, then the force will be divided by 4. It will decrease by 4 times. Distance is double only, but force is decreased by 4 times. If distance is 3 times, then force will be by 9 times. Are you getting the point? Force will be how much? It will be, if distance is by 3 times, then force will be by 6. No, 9 times. How much? Yeah, it is 9 times. If distance is 4 times, if I increase the distance 4 times, then force will decrease by 16 times. Okay, so this is the idea. Now what will happen if I bring closer? If the distance become one fourth of the, when the distance is reduced to half, now distance is half, that is m1 m2 divided by, distance is half means d by 4 d by 2 whole square. So m1 m2 divided by d square, and r2 is also 4, right? So 4 will go up, it will be g m1 m2 divided by d square, 4 I can write down here. So g m1 m2 by d square, it is f, right? So look here, 4g m1 m2 by r square, 4f. So it will be 4 times. If I bring closer, if distance is like this, if I reduce by half, then the force will be 4 times. Distance is just half, but force will be 4 times. Okay, distance is doubled, right? Then force will be divided by 4. Okay, I've shown the calculation here. I hope you can understand. So the gravitational force become 4 times the original force. Second, we know that gravitational force acting on all object is proportional to their masses. Why then heavier object does not fall faster than the lighter object? Very good question. Question says, gravitational force acting on an object depend upon mass. More mass means more force. Then why not the two objects you and elephant fall down together? Good question. Question is good. And you are also good if you are watching till now. If you are watching till now, that's a sir. We have, so in order to show if you are watching till now, then you write down sir reached. Okay, question place, or write down something like this. Sir, interesting. Write down something so that I can know, okay, someone is watching till now. I may hardly find any student watching till now, but if anyone is watching, please. So Newton's second law is F is equal to mg, which gives A is equal to g, then g is equal to gm by r square. We have discussed that gm by r square. We have derived this, right? Gm by r square. So here g value doesn't depend upon mass of an object. It depends upon independent of the falling object. Look, so when I derive this one, I have derived this one before, right? I don't need to derive again, I think. So g is equal to gm by r square. We see that g depends only on m and radius r. So it doesn't depend not on the mass of the falling object. Look, gm by r, it doesn't depend on the mass of the falling object. So object, it can have any mass, it will fall down at the same acceleration, because g value, the acceleration due to gravity, doesn't depend upon these two. Finish. We have discussed already this one, and I'm explaining here also. So if each object in the universe, if each body in the universe attracts every other body, why don't two books kept on the table comes towards each other and collide? So if everything is attracting, then why is not two books on the table? Two books on the table comes toward each other and collide. Two books attract each other. They will attract. There is force between them, but it is very small. The force is extremely weak. Why it is weak? Because the reason for it being weak is g is very small, 6.67 into 10 to the power minus 11 newton meter square per kg square, very small. And the masses of the books are very small, and m value also very small. Masses are also very small. Okay, g also very small, mass also very small. So other forces like friction between books and table, air resistance, and electromagnetic force between atoms are much stronger than weak gravitational attraction. So there are other forces. There are friction between these two. The object, the book is on the table, there is some friction. Okay, and there is air also there. There is air resistance. Okay, there are atoms and molecules which will have some electromagnetic force. There are many forces here. Okay, and the gravitational force is the weakest. That's why these two doesn't collide. The book doesn't collide. Okay, because gravitational force is very small. Okay, why it is small? Because constant is very small, 6.67 into 10 to the power minus 11. I've told you how small is that, right? Okay, another question is distinguish between capital G and small g. I've told you this question is, what is capital G? It is universal constant. Small g is acceleration due to gravity. Value 6.67 10 to the power minus 11, value 9.8 meter per second, and this is on Earth's surface. This is everywhere. Okay, everywhere. This is on Earth's surface. It is different on different. Like On moon it was 1.6, right? So it depends upon place to place. Acceleration due to gravity is different. It is not constant. Okay, this is constant, g is constant. This acceleration due to gravity, g value, small g value, it changes on different planet. On our surface it is this much. This is a scalar quantity. G acceleration is always a vector quantity. Unit Newton meter square per kg square. This is meter per second because Newton per second square. It appears in Newton law of gravitation. It appears in weight calculation. Starting from Newton law of gravitation, so that the value of g decreases as one goes above the earth surface. From Newton law of gravitation, g m by r square. What does it say? Starting from Newton law of gravitation, so that the value of g decreases as one goes above the earth's surface. It's very easy. Gm, f is equal to gm by r square. Another is force equal to mg. Now if I compare these two, I'll get mg equal to gm by r square. Now after that, g will be equal to cancel. G will be equal to gm by r square. After that, let's talk about earth surface. G naught earth surface. I'm writing g naught for earth surface. So gm by r square. This is radius of the earth. At the height above the earth surface, let's say there is some height above the earth surface. I'm writing m by r. Distance is high, right? Now if I was talking about earth surface, now I'm taking this a little bit higher than the earth surface, so this value is h, so I'm adding that. The radius is more now, the radius has increased. Okay, now gh by g naught. Gh is above height, this one. G naught is on the surface of the earth. So if I divide gh by g naught, so gh is how much? This one, gm by r plus h whole square, divided by g naught is gm by r square. G cancel, m cancel, so r will go up. So capital R square divided by r plus h whole square. R square by r plus h whole square. Okay, so r square plus r plus h whole square, which will be equal to, I can write down this one as, okay, I can write down this one as, I can write down like this, r square, I can take downside and I can write down like this also. Or I can write down r divided by r plus h, and I can add a whole square like this. And after that I can add a 1 by r. R divided by r is 1 plus h by r. I can divide downside. Okay, and I'll get the equation like this. I hope there is no problem with you in this mathematics, the derivation. Now look here. Look here. Since 1 by half, this value, okay, it is greater than 1 or not? This down value will be greater than 1 or not? Sir, it will be greater than 1. How? This down one, look here. It is 1 plus h by r square. 1 by h whole square. So 1 plus, if you are adding something h by r, h means height, and r is the radius of the earth. You are dividing and you are adding to 1. It may be very small value, but it will be greater than 1. So this value is more than 1, greater than 1. So it's greater than 1. That means if h is greater than 0, then we have, if this is greater than 1, then gh is 1 plus h by r whole square is equal to g naught. Now this one and this one, which one will be bigger? Question is, can you see here? This one you will multiply this side, and this one you will multiply here. So you'll get g naught equal to gh 1 plus h by r whole square. Now this is more than 1. This is greater than 1. Now which one will be greater? Sir, this one multiply with this one, I'll get this one. So this one will be more. Okay. So g naught will be more. G naught, what is g naught? G naught is earth surface. At earth surface, g value, right? G naught is earth surface value. So earth surface value is more than at certain height. So as you go up, g value decreases. Therefore, the value of g decreases as you go on above earth surface. We have derived, we have answer according to the question. If you don't understand, comment is there. I'm telling you again and again. Okay. Let's go next. Question number 6. We know that Earth and the moon are attracted to each other by gravitational force. Does the Earth attract the moon with a force which is greater or smaller or the same as the force with which the moon attracts the Earth? Give reason for your answer. Earth and moon are attracted to each other by gravitational force. Earth and moon are attracted to each other. Earth and moon are attracted to each other by gravitational force. Does the Earth attract the moon? Earth attract the moon with a force which is greater or smaller or the same as with the moon attract Earth. Now, if this is Earth, this is moon, Earth is attracting the moon is also attracting the Earth. Now, which force will be same? Will these two force equal, or will this force will be different? Now, according to Newton's third law of motion, for every action there is equal and opposite reaction. Okay, the Earth attracts the moon. Okay, with the same force as the moon attracts the Earth, the force will be same. The moon and Earth, moon is attracting the Earth attracting the moon. The it will be same. This is because gravitational force are mutual and equal in magnitude but opposite in direction. Okay. Now from Newton law of gravitation, force on Earth due to moon or from moon on Earth. Okay. Force on moon due to Earth. This will be equal, and equal will be given by force on G m on Earth m on moon divided by Earth square. It will be same. Either you say moon attracting the Earth or Earth attracting the moon, the force will be same, and it is given by G m on Earth m on moon divided by distance between them. Okay, so but both force have the same magnitude but acts in opposite direction. What does it mean? The force between these two will be equal. Let's say this is moon, this is Earth. Force will be same, but direction is different. Why? Because the force due to moon is in this direction, it is pulling, right? And moon Earth is this direction, so direction is different. This is this direction, and this is this direction. The direction are different for these two, so direction is different, but force magnitude is same. Let's go next question. From the universal law of gravitation, we have learned that moon attracts the Earth. Why does the Earth not move moon towards the moon? Why does the Earth not move? Okay, Earth is attracting the moon or moon attracting the Earth. Then why is not the Earth going to the moon then? Why is not the moon coming to the Earth? So Earth does move towards the moon, but this motion is not noticeable because actually Earth is moving to the moon. Moon is coming to the Earth, but it is not noticeable. We cannot understand. We cannot notice this because both Earth and moon revolve around their common center of mass. Okay, there is both are revolving. Okay, around they are revolving like this. Okay, the barycenter lies inside the Earth. Barycenter means the center of mass. Okay, common center of mass lies inside the Earth about 1700 kilometers below surface due to Earth much larger mass. From Newton's second law, A is equal to force by mass. Since Earth mass is much larger than the moon mass, okay, so Earth acceleration toward moon is much smaller. The moon acceleration toward Earth is 81 times greater than the Earth acceleration toward the. Therefore, while both moves toward each other, the moon motion is more pronounced. Okay, this is okay for you. I don't think this is quite relatable. That common center of mass. What does it mean? I'll actually tell you. This is Earth, and this is moon. Moon is very small, and center of mass of moon, sir, center of mass of moon will be center here, and Earth will be here. I don't think so. It is quite relatable to you, but anyway, I'm explaining. Center of mass means center. Okay, but if these two are combined, then center of mass will be the mass of all these two mass. Center will be somewhere here. Okay, so that's what it says. It is towards the Earth, near the Earth. Center of mass is here. Because of this, the moon will try to come to the Earth, not the Earth goes to the moon. Okay, but this is not good for you. So if you are writing an answer, so you don't need to write common center. Base center lies about this one. Don't need to write. From you can start from here. Newton's second law, A is equal to force by mass. Since Earth mass is much more larger than moon mass, Earth acceleration toward moon is much smaller. The moon acceleration is towards the Earth is 81 times greater than the Earth acceleration towards moon. This write down this essential. Don't write this one. Okay, sorry, I have included here. Okay, unknowingly I was just typing and included, but I didn't think so. It is relatable for you. Okay, this is, you are going to study this in class 11 again, so you don't need to understand now this one. If you want, don't worry, comment is there. Okay, you can ask anytime. Okay, so next question number 8. What does it say? What will happen to the force between two bodies if the mass of one of them is doubled? Mass is double. What will happen? So one mass is double, m is doubled, 2m1. So force will be doubled. So distance between them is double. If distance is double, the force will be divided by 4. We have done this one already done. So if both masses are doubled, so this one 2m1, both are double. So it will be force will be 4 times. We have already known this. Okay. Second, another is, what do you mean by weight of an object? Weight means, what is weight? Weight is force with which earth or any object attracts the body towards its center. Weight means actually a force. Okay, it is given by weight is equal to mass into gravity. M, mass of the body. Gravity, weight is a vector quantity. Weight varies from place to place. It is different for different places. Mass is same everywhere. Weight is different. Weight depends on the gravitational field. In moon, weight will be more less. In Mars, it is less. And in Jupiter, it is more. Sun, it is very high. We have discussed this. Unit of weight is Newton. So practical unit, all the things, it's not needed. This is class 11. We are going to study in class 11. CGS also no need. Okay. Suggest two methods of comparing mass of n bodies, two bodies A and B, if MA and MB. So how can you measure the? How can you compare the mass? I need to compare the mass. I can compare mass using common balance, beam balance. That is balance. You know that, right? Hanging English one, balance. Way machine that that this in market, when you go for buying sugar and all, that old one they used to use, no? The in market sell, okay, that vegetable and all auntie used to do, no? Ima used to do, no? That, right? uh, for vegetables and all. Okay, so method one, we can use common balance, beam balance. Okay, one object on A and left pen another B on another, and you are going to see, okay, if you put one object here, another object here, and see which one is more, and you'll say, okay, this object is more than this, finish. Or we can use inertial method. Okay, how can you do inertial method? You apply the force, and you apply the force and you see the acceleration. Okay, you apply same force, push same. Now where the object which is moving faster, okay, will have less, the object which is moving faster will have less mass. Okay, so you can use this method also. Question number 11, when you put an object on a spring balance, do you get the mass of an object or its well? When I put an object on a weighing machine, spring balance, you know, spring balance, right? Spring balance will give weight. Okay, a force 20 Newton acts on an body whose weight is 9.8 Newton on Earth. What is the mass of the object and how much it is acceleration? Force 20 Newton, weight is acts on an object whose weight is 9.8 Newton on Earth. What is the mass of the object? I need to find out mass and I need to find out acceleration. Okay, so let's go. So force is, how much force is applied? 20 Newton. Weight 9.8. Acceleration G is same, right? 9.8 meter per second square. Formula I can use, weight is equal to mass into gravity. So weight how much? 9.8. Mass how much? Mass. Gravity how much? 9. Acceleration due to gravity 9.8. Mass is equal to 9.8 divided by 9.8. So I got 1 kg. Mass is 1 kg from this formula. Second, I need to find out acceleration. Acceleration is force equal to mass into acceleration. I know mass. Mass is 1 kg. Force is how much given in the question? 20 Newton. Acceleration will be, A will be equal to 20 meter per second square. Force equal to ma, 20. Acceleration, you can copy the answer. Okay, it is very written. I hope you understood. This is not that difficult also. I'm explaining very fast. You may find it, sir, you're very fast. Copy it. If you don't understand, comment is there. I'm not explaining very detailedly, step by step. The reason is you'll not watch. Okay, even hardly any student is watching till here. Okay, let's go next. A stone is released from top of the roof. whose height is 19.6 meter. Calculate its final velocity just before reaching the ground. A stone is released from top of the roof whose height is 19.6 meter. Calculate its final velocity just before reaching the ground. Stone is released from the top of the roof. Height is 19.6. Calculate the final velocity. I think I've calculated this. I don't know. I think so. How can I calculate? Height is there. A kinematic equation. This is, I don't know why am I writing like class 11. So v square is equal to u square plus 2as. I'm going to use this formula, and I have calculated this already. Okay, I have calculated it. I've given you the example also. If you want to write down, you can write down. But for you, you don't need to write down kinematic equation using equation of motion. Okay, 2as, and instead of a you are writing g. Okay, so calculate, you can calculate this one. Okay, let's go next. A ball which is thrown upward vertically returns to the earth's surface after 8 seconds. Fine. Okay, ball which is thrown upward vertically. So there ball is there, it is thrown upward vertically, and it returns to the earth after 8 seconds. Okay, so time taken is 8 seconds. G value is 9.8 meter per second square. Okay, so now find the initial velocity with which it is thrown up. So what is the speed this ball is thrown up? U value. How much? How much speed it is going up? Sir, after the ball reaches here, it reaches here, and it will fall down after that. It will fall down. This after reaching here, after the ball reaches here, it will fall down. So when it reaches here, it will stop and it will fall down. If I throw the ball up, it will reach here and it will fall down. So at this position, the final speed, it is zero. Understand this. At maximum height, the final velocity is zero. G is 9.8 meter per second square. Now let's go with the first formula. I'm going to use all the three formula of motion. Okay, v is equal to u plus at. Now sir, v equal to u plus at. What is the question asking? Find the initial velocity. Initial means u. V is 0. U I need to find out. A sir, how much? A acceleration due to gravity, how much? Acceleration due to gravity. Sir, acceleration due to gravity is 9.8 into sir time how much? 8 second, right? So 8 second it goes to reach up and come down. How much time will it take to just reach? Sir, half of 8 seconds. So it will be 4. Okay. So time to reach the maximum height. Time to reach the maximum height is, okay. Time to reach the maximum height is half 4. So apply first equation of motion. At maximum height, v will be 0. So v is 0. U minus 9.8 into 4. I need to find out u. So 9.8 into 4. If I multiply, it will be 39.2 meter per second. So this is u value. So I've calculated u like this. Second, the question is asking us to find the maximum height. So I can use the equation, use third equation of motion. If you want to take the screenshot, you can take the screenshot now. Okay, so let's do the maximum height. Use third equation of motion. V square is equal to u square minus 2gh. Now v square is how much, sir? Final velocity. V square 0. U how much we got, sir? We have calculated 39.2. 2g. G is how much? H I need to find out. Sir, h I can find out. You could just put in the equation and find out h. Third, I need to find out after 5 seconds what will happen. Let's say I'm throwing the object, it will reach certain height and it will fall down. Sir, it takes 8 seconds. That means 4 seconds it will reach up. 8 seconds, 5 seconds, what will happen? What will be the here? What is the position? Position means height. How much will be the s? S means height. So I can find out s using the third equation. S equal to ut plus half at square. S is how much? Ut. U is how much? 39.2. T time. Time is given 5 seconds. Half. G is 9.8. T is 5. So I got 39.2 into 5 minus 1 by 2 into 9.8 into 5 square. Okay. So this is the derivations. I hope you can understand. And if I calculate this, I found out the value of S to be 73.5 meter. Okay, let me note. If you don't understand, comment is there. Please write in the comment. I'll explain that question for you. I'll make a very separate video explaining that question for you step by step. Just tell me which question you don't understand and what you don't understand. Okay, that portion I'll explain it very detailedly. I'll make a very separate video. Question number 15. A stone is dropped from a height of 49 meters. Simultaneously, another ball is thrown upward from the ground with a speed of 40 meters per second. When and where do the two stones meet? One ball is falling down from 49 meter, and another ball you are throwing upward with speed of 40 meter per second. Where will they meet? Okay, height from the which is 49 meter. Initial velocity of the drop stone is u is equal to initial velocity, u is equal to 0. Initial velocity of the thrown ball, the ball that you are throwing up, initial velocity is 40 meter per second. Acceleration due to gravity is 9.8 meter per second square. Okay, formula used is s is equal to ut plus half at square plus half at square. Let me use this formula. So what do we need to find out? I need to find out. So before doing that, we are going to derive something. We are going to calculate. So this object is falling down and this object it is going up. Okay, now they are going to meet each other here. Let's say both of them, they are going to meet here. They're going to meet each other here. This one will come down here, this one will go up here, and then meet out here. So this meet. Okay, so this time, let's say time, this is t, and the height is h. This height, the meeting height is h from the ground. So from distance traveled by this object is 49 is the total height, and h is the height from the ground to this. So distance traveled by this one will be 49 total, 49 minus this one, the smaller one. Okay, so 49 minus h. So s is 49 minus h. U initial velocity is 0, half a t square. So I need to find out t square. So I can find out t square and h. Both I don't know. For the thrown ball distance travel, for now the another object is you are throwing up. The height is h. H equal to, I can use the same formula and I'll get h, same equation. Now I can solve these two equation. 4.9 t square minus 4.9 t square I can cancel, or I can add these two equation. If I add 4.49 minus h, look, if I add these two, 49 minus h, 49 minus h plus h, 49 t square, 40 t, 4.9 t square, these two cancel, h cancel, right? So I got 40 t is equal to 49. So t value I got like this, and I can calculate h value also by putting in this equation. Equation number 2 I can put here, this equation I can put here and find out the value of h. Okay, so you can take the screenshot if you want to do and check. I've written on very step by step. There is not even a single step missed. But anyway, if you don't understand, I'm telling you again and again, I'm here. Okay, I'm here. So calculate the value of h. Continue here. Let's go next. Question number 16. A particle is taken to a height r above the earth's surface, where r is the radius of the earth. The acceleration due to gravity of the earth at that point is, this is MCQ question. For question number 16, answer is A. And how to calculate, look, I've given the calculation step by step here. Second, question number 17, answer is D. Check it out. Okay, I've given the steps here. Question number 16, question number 18, answer is B. Answer is B. When an object is thrown up, the force of gravity is, when object is thrown up, the force of gravity is down. Force is always attracting, the earth will attract this one, it is always downward. In the region I've given like this, look, solution region is also given. And I hope this is the end, and I hope you understood. Thank you so much. The video is around 1 hour and 30 minutes, and I hope you understood. Okay, and if you find any difficulty here and there, if there is anything that you don't understand, please, comment section is there, write down in the comment below. Okay, I'm happy to help you. That's all. Thank you so much.